Hey, what's going on, y'all? It's Sean, the owner and lead tutor of Math Swap Tutoring. And today I want to talk about what in the world a root is. When we're talking about Algebra 1, and talking about square roots, cube roots, what is a root aside from something that comes from like a plant or something like that, right? Anyway, let's go ahead and get into this. And I want to encourage you, like, really pay attention because you can understand this. Sometimes we have these things like that. Some of these math concepts are just these vague things that can't be understood, but it really isn't like that. I promise you, if you take the time, you'll see what it is. All right, so the question is, what is a root? And again, that's like when we're talking about square roots and stuff like that. All right, so let's give, starting out, let's give a definition here. We're gonna make sure this is black. All right. So, and I would encourage you, whenever I'm giving notes, I would encourage you to write them down. That's what I did when I was in school. Actually write the notes down yourself, read over them yourself so you can really kind of start to conceptualize what's being talked about. All right, so let me just put this here. The nth root of a number is a number that, if used as a factor n times, in other words, if you have n of this number multiplied times each other, and it'll make more sense whenever I actually write out the math of it, gives the original or IGINL number. All right, so now let us kind of like make real sense of this. So the nth root of a number is a number that, if used as a factor n times, remember what a factor is. A factor is the factor of a number is a number that if you multiply it times something else, you get the original number. So like, for example, a factor of 6 is 3, because if you multiply 3 times 2, you get 6. 2 is also a factor of 6 because if you multiply 2 times 3, you get 6. So any number that if you multiply it times something else, you get the original number. So the nth root of a number is a number that if you use it as a factor itself n times, if you have n is going to stand for some sort of number. So if you have, for example, 2 number 2s, you can get 4. So that means that 2 is a second root of 4 because n is 2. So that means that 2 is a second root of 4 because you have 2 2s multiplied times each other and you can get 4. All right, so let's write out the mathematical representation of that. So that looks like this. So the nth root of some number x. So this basically is the nth root of x. That's what it stands for. When you have this kind of like funny looking, almost looks like a division kind of thing with an n there, that means the answer to this is the nth root of x. And a root, again, is a number that if you multiply it, if you have n of them multiplied times each other, you get the original number. So let's make it practical by using numbers. All right, so say, for example, you had the second root of 1. So the answer to this is going to be the second root of 1. Whatever this is going to evaluate to the second root of 1. So in other words, what is the second root? Now note that second root is the same as square root. Usually, if you're talking about square root, you're not going to have any number here because it's going to be an understood 2 there. That's the most common root that people find. So even if you look on your calculator, you're just going to see this right here. You're not going to see a 2 there, but if it's blank, that means it's 2. Now, if it's something other than 2, 3, 4, 5, 6, you're going to have the number there. Or your calculator even has like this kind of thing where you can kind of like tell your calculator, okay, what root is it? So anyhow, what is the second root of 1? In other words, what is a number that if you use it as a factor 2 times, it gives you the original number? Easy, 1. Because if you use it as a factor 2 times, in other words, if you have 2 1s multiplied times each other, 2 is determined by that n, you get the original number. Okay. So this may not be the best example because all you have is 1s here. But let's look at this. Let's look at the second, or we're going to start to call it square root. Let's look at the square root of 4. Square being the second root. What is the square root of 4? In other words, what is a number that if you use it as a factor 2 times, in other words, if you have 2 of this number multiplied times each other, you get the original number 4. What is a number that if you just take it by itself 2 times, you get 4? It's 2. Okay, because if you have 2, according to n equals 2, if you have 2 of those being multiplied times each other, you get the original number. Excuse me. So the square root of 4 is 2. Okay, let's do one more. What's the square root of 9? What is a number that if you have 2 of them being multiplied times each other, you get the original number 9? 3. How do we know? Because if you have 2 number 3s, I'm saying 2 of them according to that n, and they're multiplied times each other, you get the original number. Good. All right, now let's look at another example of not square root, but let's look at cubed root, for example, the cube root of 8. And you just kind of see how this stuff works. What is a number? What is the cube root or the third root of 8? In other words, what is a number that if you multiply it times itself 3 times, you get the original number, which is 8? It's 2, because if you have 3 number 2s being multiplied times each other, you get 8. 2 times 2 is 4, times 2 is 8. See? So that means that the cube root of 8 is 2, because 3 of them will give you 8. Now take your time to like go back and look at it as many times as you need to until your brain kind of locks it in. But that's the way this root stuff works. And it really is that simple. Now, just to give you some definitions, this n right here is known as the index. And then that x is what's called your radicand. I'm not really sure how much you'd be asked about that when you're taking your test and stuff like that, but it's good to know nonetheless. All right, now let's go a little bit deeper with this. And again, I encourage you to take your time and like look at this as many times as you need to gain some understanding. Okay. All right. So this next thing, and I'll leave that stuff there. So check it out. So if n is positive even integer, then the nth root of x is positive and real. All right, let's break all this down and listen very carefully. So if n, that index, when we're talking about, an nth root, If it is positive, which means greater than 0, and an even integer, then that means if even, that's 2, 4, 6, 8, 10, 12. Integer just means it's kind of like a whole number. So the numbers that we're talking about when we say positive even integer, we're talking about 2, 4, 6, 8, and so on and so forth. So if n is 2, 4, 6, 8, 10, 12, some sort of positive even integer, then the nth root of x is going to be positive. That means it's going to be greater than 0. And it's going to be a real number. Real just means it's the opposite of imaginary numbers, which is basically an imaginary number gets created when you try to take, for example, like an even root of a negative number. You get a number that has the letter I after it, not the subject of this particular lesson. All right. So that's all that means. Now, if n is positive, a positive, let me see, odd integer, then the nth root of x is real, but it's not necessarily positive. So let's break it down again. So if n is a positive odd integer, so positive means greater than 0, odd means 1, 3, 5, 7, 9. You usually don't take the first root of a number, but anyhow. So if you have, that means that n would be 5, 7, 9, so on and so forth. So if n is one of these positive odd integers, basically the answer to this, the nth root of x, is going to be, it's going to be real, but it's not necessarily going to be positive. All that really means is this number x can be, let me see how to put this. This number x can be a negative number, and you still get something that is not imaginary when you take the nth root of the negative number. Let me put it to you this way. Say, for example, you had, let me see, the second root of 16, the square root of 16. Okay, that's what times what will give you 16. Since we're talking about 2 times, that's going to be 4, okay? Now, if you want to take the square root of negative 16, so 4 times 4 will give you 16, but will something times something give you negative 16? No. If you're multiplying two numbers by each other, then one has to be negative for the answer to be negative. If both of them are negative, then the answer is positive. So when you take the square root of a negative number or the even root of a negative number, you get a situation where you have an imaginary number. So this is 4i, beyond the scope of this. Now, watch this. Let's say we were taking the cube root of 8 again. We know that that's 2 because 2 times 2 times 2 is 8. Now, what if we were taking the cube root of negative 8? Now, the answer to this is negative 2. To note, this is not imaginary now. It is a real number. It's not positive, but just like we said, it's still real. Why? Because negative 2 times negative 2 times negative 2 will still give you negative 8, because negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So again, that's the illustration of this right here. If n is positive and odd, that means that the answer to this is going to be real. Okay. So, but here, if n is positive and even, 2, 4, 6, 8, 10, 12, then we know that the answer is going to be positive and real. Okay. So again, you can't really find, this is not going to be a real number if x is negative. If this is going to be positive and even, if the index is positive and even, then you get a positive real answer if x is not negative. Here, it doesn't matter if x is negative or positive. because n is positive and odd, okay? So just really take your time, especially to look at this example here to try to break that down. If it's still not clear enough, make sure you leave a comment. All right, so I'll let that be it. I'm gonna record a little bit more in a second video on this, talking about rational roots and irrational roots, because I don't want this video to be too long. But anyhow, I hope this is helpful. Watch it as much as you need to. Do examples, all that kind of stuff, and just keep on showing yourself until it clicks, okay? If you have any sort of helpful comments to make this video better, just let me know, and have fun. All right.